Chemistry Notes Chapter 01 for Calzes 9. 10. Exercise. Section A, Multiple Choice Questions. Tick mark the correct answer. 1. The branch of chemistry which deals with hydrocarbons, A. Industrial chemistry, B. Inorganic chemistry, C. Organic chemistry, D. Physical chemistry. 2. The atomic mass of an element expressed in gram is, A. Gram molecular mass, B. Gram atomic mass, C. Gram formula mass, D. Mole. 3. Which of the following can be separated by physical means? A. Mixture, B. Element, C. Compound, D. Substance. 4. The molar mass of H2SO4 is, A. 98A.M.U, B. 9.8 gm, C. 98 gm, D. 9.8 A.M.U. 5. The molecule consist of two atoms is, A. Monoatomic molecule, B. Polyatomic molecule, C. Heteroatomic molecule, D. Diatomic molecule. 6. A formula that indicates actual number and type of atoms in a molecule is called, A. Chemical formula, B. Empirical formula, C. Molecular formula, D. Formula mass. 7. Ethyl alcohol was prepared by, A. Ibn Sina, B. Al-Razi, C. Al-Biruni, D. Jabir Binhan. 8. Which of the following is a homoatomic? A. H2, B. NH3, C. H2O, D. CO2. 9. The empirical formula of hydrogen peroxide is, A. H2O2, B. HO, C. O, D. O2H210. A piece of matter in pure form is termed as, A. Radical, B. Mixture, C. Compound, D. Substance. Section B, Short Questions. 1. Differentiate between the physical and analytical chemistry. S.No. Physical chemistry, analytical chemistry. 1. Physical chemistry is the branch of chemistry which deals with relationship between composition and physical properties of matter with the changes in them. Analytical chemistry is the branch of chemistry which deals with separation and analysis of kind, quality, and quantity of various components in given substance. 2. It deals with the laws and principles governing the combination of atoms and molecules in chemical reactions. It used in chromatography, electrophoresis, and spectroscopy. 2. Write down the classification of molecule. Molecules are made up of atoms that are held together by chemical bonds. These bonds form as a result of the sharing or exchange of electrons among atoms. Molecules are classified as mono, di, tri, polyatomic molecules, homoatomic molecules and heteroatomic molecules. Monoatomic molecules consist of one atom, e.g. He, Ne, Ar, Kr, Xe and Rn. 2. Diatomic molecules consist of two atoms, e.g. N2, O2, Cl2, Br2, I2 etc. 3. Triatomic molecules consist of three atoms, e.g. H2O, CO2, H2S etc. 4. Polyatomic molecule consist of many atoms, e.g. H2SO4, CH4, C6H12O6 etc. V. Homoatomic molecule consist of same type of atoms, e.g. O3, P4, S8 etc. 6. Heteroatomic molecule consist of different type of atoms, e.g. H2O, CO2, NH3, H2SO4 etc. Chemistry Notes Chapter 01 for Calzes 9. 11. 3. Identify the differences among the following. A. Atom and ion. Atom is the smallest particle of an element. Atom can or cannot exist independently and take part in chemical reaction. Atom is electrically neutral. Ion is the smallest unit of ionic compound. Ion cannot exist independently and surrounded by oppositely charged ions. Ion has negative or positive charge. B. Molecule and molecular ion. Molecule. Molecular ion. Molecule is the smallest particle in a chemical element or compound that has chemical properties of that element or compound. Molecule is always neutral. Molecule is stable unit. Molecule is formed by combination of atoms. Examples are H2O, NH3, CO2, etc. Molecular ion is formed by the gain or loss of electrons by a molecule. Molecular ion have positive or negative charge. Molecular ion is a reactive species. Molecular ion is formed by the ionization of a molecule. Examples are NH4+, H3O+, SO4 etc. C. Compound and mixture. Compound. Mixture. Compound is formed by a chemical combination of atoms of the elements. Constituent of compound lose their identity and form a new substance with new properties. Compounds have fixed composition by mass. Components cannot be separated by physical means. Every compound represented by chemical formula. Compounds have homogeneous composition. Compounds have sharp and fixed melting points. Mixture formed by the simple mixing of the substances. Constituents of mixture retain their properties in mixture. Mixtures have no fixed composition by mass. The components can be separated by physical means. It consists of two or more components and does not show any chemical formula. Mixtures have homogeneous as well as heterogeneous composition. Mixtures do not have sharp and fixed melting points. 4. Define the following terms. A. Gram atomic mass. The atomic mass of an element expressed in gram is called gram atomic mass. It is also called 1 mole. 1 gram atom of oxygen equals 16.00 G equals 1 mole of oxygen atom. 1 gram atom of carbon equals 12.00 G equals 1 mole of carbon atom. 1 gram atom of nitrogen equals 14.00 G equals 1 mole of nitrogen atom. It means 1 gram atom of different elements has different masses. Chemistry Notes Chapter 01 for Calzes 9. 12. B. Gram molecular mass. The molecular mass of an element or a compound expressed in gram is called gram molecular mass. It is also called 1 mole. 1 gram molecule of oxygen, O2, equals 32.00 G equals 1 mole of oxygen molecule. 1 gram molecule of water, H20, equals 18.00 G equals 1 mole of water. 1 gram molecule of ethanol, C2H5O, equals 46.00 G equals 1 mole of ethanol. C. Gram formula mass. The formula mass of an ionic compound expressed in grams is called gram formula mass. It is also called 1 mole. 1 gram formula of NaCl equals 58.5 G equals 1 mole of sodium chloride. 1 gram formula mass of CaCO3 equals 100 G equals 1 mole of calcium carbonate. 5. Write down the chemical, empirical and molecular formula of the following: sulfuric acid, carbon dioxide, glucose, benzene. Compound name, empirical formula, molecular formula, sulfuric acid H2SO4 H2SO4, carbon dioxide CO2 glucose CH2OC6 H12O6, benzene CHC6H6. 6. What is free radical? Free radicals are atoms and group of atoms having number of unpaired electrons. It is represented by putting a dot over the symbol of an element. For example, HO, ClO, H3CO, etc. Free radicals are formed when homolytic breakage of bond between two atoms takes place by the absorption of heat or light energy. Free radical is very reactive chemical species. 7. Describe relationship between empirical and molecular formula. Explain with examples. Molecular formula is an integral multiple, 1, 2, 3 etc., of the empirical formula. Molecular formula equals empirical formula, n where n equals 1, 2, 3, etc. Example 1. Benzene has molecular formula C6H6, which has simplest ratio of hydrogen and carbon is 1:1, so the empirical formula becomes CH. 2. Glucose has molecular formula C6H12O6. It shows the ratio as follows: C6H12O6 6:12:61, 2, 1C, H2O. 8. Explain why hydrogen and oxygen are considered as element whereas water is compound. An element is a substance made up of same type of atoms. Element are homogeneous. Element have same atomic number and cannot further decompose into simple substances by ordinary means. For example, hydrogen, oxygen, etc. Compound is a substance formed when two or more elements are chemically bonded together in a fixed ratio by mass, as a result a new entirely different properties possessing substance formed. For example, hydrogen and oxygen are chemically bonded together to form water, which is a compound. Chemistry Notes Chapter 01 for Calzas 9. 13. Section C, Detailed Questions 1. What do you mean chemical species? Explain ion, molecular ion, and free radical. Chemical species. If one molecule is identical to another, we can say they are the same chemical species. Chemical species is a chemical entity, such as particular atom, ion, or molecule. Ion is an atom or group of atoms having a charge on it. The charge may be positive or negative. There are two types of ions, cations and anions. The cations are formed when an atom loses electrons from its outermost shells. For example, Na+, K+ are cations. The following equation shows formation of cations. Na++, 1e. An atom or group of atom that has a negative charge on it is called anion. Anion is formed by the gain or addition of electrons to an atom. For example, Cl and O2. Following examples shows formation of an anion by addition of electrons to an atom. Cl plus 1e Cl. Molecular ions, when a molecule loses or gains electrons called molecular ions. Molecular ions also possess positive or negative charge like any ion. If it has negative charge known as anionic molecular ions, if they has positive charge known as cationic molecular ions. For example, NH4+. Free radicals. Free radicals are atoms and group of atoms having number of unpaired electrons. It is represented by putting a dot over the symbol of an element. For example, H, Cl, H3C, etc. Free radicals are formed when homolytic breakage of bond between two atoms takes place by the absorption of heat or light energy. Free radical is very reactive chemical species. 2. Write down the applications of chemistry in daily life. Our planet Earth has only life in the all-planet of universe, due to existence of water, H2O. The water is basic need of human, animals and plants. The chemical reactions take place in human, animals and plants. Disorder in these reactions may cause different diseases, which may be overcome with the help of chemistry. The role of chemistry in daily life is unavoidable fact. Cooking, eating and digestion of food are purely chemical processes. Construction, cleaning and washing of our homes are dependable on chemistry. The production of fertilizers, glass, plastic, synthetic fiber, polymer, ceramics, petroleum products, soaps, and detergents are based on chemistry. The diseases transmitted through impure drinking water as cholera, typhoid, dysentery, skin and eye infections can be controlled with the help of chlorine treatment to kill the pathogenic organism to obtain pure water. The chlorine is most important chemical which used commercially to produce more than 1,000 compounds which are used in chemical industry as bleaching agent, disinfectants, solvents, pesticides, refrigerates, PVC and drugs are miracles of chemistry. 3. Explain in detail empirical and molecular formula. Empirical formula. The formula showing minimum relative numbers of each type of atoms in a molecule is called empirical formula. Empirical formula shows simplest ratio of each atoms present in a molecule. Empirical formula does not show the actual number of atoms in the molecule. Chemistry Notes Chapter 01 for Calzes 9. 14. Empirical formula tells us the type of element present in it. For example, 1. Benzene has molecular formula C6H6, which has simplest ratio of hydrogen and carbon as 1:1, so the empirical formula becomes CH. 2. Glucose has molecular formula C6H12O6. It shows the ratio as follows: C6H12O6 6:12:61, 2, 1C, H2, O. Molecular formula. The molecular formula is the formula which shows actual number of atoms of each element present in a molecule. Molecular formula is derived from empirical formula. Molecular formula mass calculated by adding atomic weights of its atoms. Molecular formula of a compound may be same or multiple of empirical formula. For example, molecular formula of benzene is C6H6, which have 6 carbon and 6 hydrogen atoms. Molecular formula is an integral multiple, 1, 2, 3 etc., of the empirical formula. Molecular formula equals empirical formula, n, where n equals 1, 2, 3, etc. 4. Explain the steps for balancing the equation. Balancing of chemical equation. We can balance the equation by following steps. Write the correct formula of all reactants on the left side and products on the right side of an arrow. Balance the number of atoms on each side. If the number of atoms may appears more or less than other side, balance the equation by inspection method. Multiply the coefficient with formula to make the number of atoms same on the both reactants and products sides of equation. The covalent molecules of hydrogen, nitrogen, and chlorine exist as diatomic molecules, e.g. H2, O2, N2, and Cl2. We must write them as diatomic molecule rather than isolated atoms in chemical equation. Finally, check the equation to be sure that number and kind of atom are same on the reactant and product side. If yes, now equation is balanced. 5. Name the branches of chemistry and discuss any 5 branches. Branches are already discussed above. Section D, Numericals. 1. Balance the following equations by inspection method. A. NH3 plus O2 NO plus H2O. Step 1. Write correct formula of all reactants on left side and product on right side of an equation. NH3 plus O2 NO plus H2O. Step 2. Balance the number of atoms on each side. Reactants products N, 1, N, 1, H, 3, H, 2, O, 2, O, 2. Step 3. Now multiply the formula, H2O, with coefficient 6 on product side and 5 in front of oxygen on reactant side to balance the oxygen atoms. Chemistry Notes Chapter 01 for Calzes 9. 15. NH3 plus 5O2 NO plus 6H2O N, 1, N, 1, H, 3, H, 12, O, 10, O, 7. Step 4. Now again check and balance the equation by placing 4 in front of NH3 and NO on both sides. 4 NH3 plus 5O2 4 NO plus 6H2O N, 4, N, 4, H, 12, H, 12, O, 10, O, 10. Now this chemical equation is balanced. B. NO 3 NO 2 plus O2. Step 1. Write correct formula of all reactants on left side and product on right side of an equation. NO 3 NO 2 plus O2. Step 2. Balance the number of atoms on each side. Reactants products K1, K1, N1, N1, O3, O4, Step 3. Now multiply the formula, NO3, with coefficient 2 on reactant side. 2 NO3 NO2 plus O2. Reactants products K2, K1, N2, N1, O6, O4. Step 4. Now balance the equation by placing 2 in front of NO2 on product side and check again. 2 NO3 2 NO2 plus O2 reactants products K2, K2, N2, N2, O6, O6. Now this chemical equation is balanced. C, Ca plus H2O Ca, O2 plus H2. Step 1. Write correct formula of all reactants on left side and product on right side of an equation. Ca plus H2O Ca, O2 plus H2. Step 2. Balance the number of atoms on each side. Reactants products Ca1, Ca1, H2, H4, O1, O2. Step 3. Now multiply the formula, H2O, with coefficient 2 on reactant side. Ca plus 2H2O Ca, O2 plus H2 reactants products. Chemistry Notes Chapter 01 for Calzes 9. 16. Ca1, Ca1, H4, H4, O2, O2. Step 4. Now again check. Ca plus 2H2O Ca, O2 plus H2. Now this chemical equation is balanced. D. NaHCO3 Na2 CO3 plus H2O plus CO2. Step 1. Write correct formula of all reactants on left side and product on right side of an equation. NaHCO3 Na2 CO3 plus H2O plus CO2. Step 2. Balance the number of atoms on each side. Reactants products Na1, Na2, H1, H2, C1, C2, O3, O6. Step 3. Now multiply the formula, NaHCO3, with coefficient 2 on reactant side. 2 NaHCO3 Na2 CO3 plus H2O plus CO2 reactants products Na2, Na2, H2, H2, C2, C2, O6, O6. Step 4. Now check again. 2 NaHCO3 Na2 CO3 plus H2O plus CO2. Now this chemical equation is balanced. E. CO plus O2 CO2. Step 1. Write correct formula of all reactants on left side and product on right side of an equation. CO plus O2 CO2. Step 2. Balance the number of atoms on each side. Reactants products C1, C1, O3, O2. Step 3. Now multiply the formula, CO2, with coefficient 2 on product side. CO plus O2 2 CO2 reactants products C1, C2, O3, O4. Step 4. Now again check and balance the equation by placing 2 in front of county on reactant side. 2 CO plus O2 2 CO2 reactants products C2, C2, O4, O4. Now the chemical equation is balanced. Chemistry Notes Chapter 01 for Calzes 9. 17. 2. Calculate the formula mass, A.M.U, of the following: Al2O3, MgCl2, NaCl, NO3. I calculate the formula mass of Al2O3. Solution atomic mass of Al equals 26.98 A.M.U. Atomic mass of O equals 16 A.M.U. Formula unit equals Al2O3. Formula mass of Al2O3 equals 2, 26.98, plus 3, 16, equals 53.96 plus 48 equals 101.96 A.M.U2. Calculate the formula mass of MgCl2. Solution atomic mass of Mg equals 24.3 A.M.U. Atomic mass of Cl equals 35.453 A.M.U. Formula unit equals MgCl2. Formula mass of MgCl2 equals 1, 24.305, plus 2, 35.453, equals 24.305 plus 70.906 equals 95.211 A.M.U3. Calculate the formula mass of NaCl. Solution atomic mass of Na equals 22.9897 A.M.U. Atomic mass of Cl equals 35.453 A.M.U. Formula unit equals NaCl. Formula mass of NaCl equals 1, 22.9897, plus 1, 35.453, equals 22.9897 plus 35.453 equals 58.4427 A.M.U4. Calculate the formula mass of NO3. Solution atomic mass of K equals 39.0983 A.M.U. Atomic mass of N equals 14.0067 A.M.U. Atomic mass of O equals 15.9994 A.M.U. Formula unit equals NO3. Formula mass of NO3 equals 1, 39.0983, plus 1, 14.0067, plus 3, 15.9994 equals 39.0983 plus 14.0067 plus 47.9994 equals 101.1032 A.M.U3. Calculate the molecular mass, A.M.U, of the following: C2H5O, H2O, NH3, CO21. Calculate the molecular mass of C2H5O. Solution atomic mass of C equals 12.0107 A.M.U. Atomic mass of H equals 1.0079 A.M.U. Atomic mass of O equals 15.9994 A.M.U. Molecular mass of C2H5O equals 2, 12.0107, plus 6, 1.0079, plus 1, 15.9994, equals 24.0214 plus 6.0474 plus 15.9994. Chemistry Notes Chapter 01 for Calzes 9. 18. Equals 46.0682 A.M.U2. Calculate the molecular mass of H2O. Solution atomic mass of H equals 1.0079 A.M.U. Atomic mass of O equals 15.9994 A.M.U. Molecular mass of H2O equals 2, 1.0079, plus 1, 15.9994, equals 2.0158 plus 15.9994 equals 18.0152 A.M.U3. Calculate the molecular mass of NH3. Solution atomic mass of N equals 15.9994 A.M.U. Atomic mass of H equals 1.0079 A.M.U. Molecular mass of NH3 equals 1, 14.0067, plus 3, 1.0079, equals 14.0067 plus 3.0237 equals 17.0304 A.M.U4. Calculate the molecular mass of CO2. Solution atomic mass of C equals 12.0107 A.M.U. Atomic mass of O equals 15.9994 A.M.U. Molecular mass of CO2 equals 1, 12.0107, plus 2, 15.9994, equals 12.0107 plus 31.9988 equals 44.01a.m.u. 4. How many moles are required to prepare 40 gm of H2SO4? Solution: given mass of H2SO4 equals 40 g, molecular mass of H2SO4 equals 98a.m.u. Number of moles equals number of moles equals known mass of a substance, molar mass of the substance. Number of moles of H2SO4 equals 40. 98 equals 0.408 moles of H2SO4. 5. Calculate the number of moles and number of molecules present in the following: A. 16 g of H2CO3, B. 20 g of C6H12O6. A. Calculate the number of moles, number of molecules present in 20 g of C6H12O6. Solution: molecular weight of carbonic acid, H2CO3, equals 2x1 plus 12x1 plus 3x16 equals 62.03 gm. Weight of H2CO3 equals 16 gm. Number of moles equals 16. 62.03 equals 0.2579 mole. Number of molecules equals number of moles. XNA equals 0.2579 x 6.02 x 1023 equals 1.55279 x 1023 equals 1.55279 x 1023 molecules of glucose. Chemistry Notes Chapter 01 for Calzes 9. 19. B. Calculate the number of moles, number of molecules present in 20 g of C6H12O6. Solution: molecular weight of glucose, C6H12O6, equals 6x12 plus 12x1 plus 6x16 equals 180. Weight of C6H12O6 equals 20 gm. Number of moles equals 20. 180 equals 0.1111 mole. Number of molecules equals number of moles. XNA equals 0.1111 x 6.02 x 1023 equals 0.66889 x 1023 equals 6.68889 x 1022 molecules of glucose.